work together and we need to be near to exchange some information about police investigations. Yesterday they came to see me and told me they had a new record for our laboratory. At 2 p.m. they found a person who was killed at his home. No information has been yet released, but the victim is a 25-year-old man. He worked as a barman and was apparently like someone else, like a friend you can have, so we should resolve the investigation. Today, few processes are more important to society than solving crimes, both to protect the society, the public from criminals, and to protect innocents from unjust punishment. So very often the strength of prosecution rests on the ability of law enforcement personnel to connect the accused with the victim by matching physical evidences from the crime scene or a victim with trace evidences found on or about a person accused. That's why I suggest presenting you the progress of this criminal investigation to understand the forensics investigators' work. Actually, we are forensics chemists who perform specialized analysis to identify materials and learn the nature of such evidences. Nowadays, we have a lot of analytical techniques which complete the traditional methods of analysis. Several fields differ: body fluid, body remains, firearms and explosives, and the composition and identity of materials. First, go back in time to trace the history of forensics chemistry. Actually, it dates from the Egyptian, Greek, and Romans. Poison were used both for murder and as a means of execution with the hemlock, and were studied by the first chemist, Democritus, who communicates some of his findings to Hippocrates. However, guilt was determined largely by circumstantial evidences and hearsays. Later, the blended trial of 1752 was the first instance of an actual chemical test of poison, and the Margaux test, developed in 1836, was the first reliable analysis that could show scientifically that arsenic was present in the body of a victim. Advances in chemistry led gradually to analyze more and more samples and get closer to the truth. With the discovery of microchemistry to identify chemical composition of tiny particles and chromatography, we have a lot of techniques to. Hello everybody, here I am in my desk just next to the forensics laboratory to help you to discover the forensics chemistry. Actually, I'm the leader of this laboratory, which is located just next to the police station to find what happened today. Secondly, I suggest you to discover different techniques that we often use to analyze samples of a crime scene. Margaux, our blood track specialist, will present you two techniques to identify blood in a crime scene, and Marie-Rine, our toxicologist, are going to explain you the test that she made to identify drugs or substance in blood of the victim. Let's go.
Luminol is used by by crime scene investigator to detect trace of blood, even if it has been cleaned or removed. The investigator spray a solution of luminol and after antioxidants, and the iron present in blood catalyze the reaction of the luminescence of the luminol. Usually a solution containing peroxide, hydrogen peroxide is used as an activator. Now I'm going to explain you the reaction of the luminol and iron. So we got the luminol in a basic solution, and we put the iron, which catalyzes the oxidation and excitation of the luminol. And after, to come back to the fundamental states, it emits light, which explains the luminescence of the reaction. As we know, blood contains red blood cells, and red blood cells contain iron. To show the effect of the luminol, we assimilate the blood to a solution of potassium ferricyanide. So first, we put the luminol into the beaker, like this. After we put coloring agents, just a little bit, like this. In another hand, we put the solution of potassium ferricyanide into another beaker. And we add the hydrogen peroxide. And after we can see the effect of the luminol. So we can see the luminescence of the luminol into the beaker. We can do the same with another coloring agent like fluorescein. So to do the Castel-Meyer test, we have to prepare a phenolphthalein reagent. So we put 0.2 of phenolphthalein. After we put 2 grams of potassium hydroxide. And after we put 1 gram of zinc. And to finish, 10 millimeter of water. And we put the mix to boil until the mix become To do the Kastelmeyer test, first we have to collect some blood in a swab, like this. And after we clean it with water. After we put a drop of hydrogen peroxide and a drop of phenolphthalein reagents. And we wait for 5 seconds to have the result. We can see that the swab turned pink and that's the sign that there is blood in this case. So we do the same test with the swab without blood. So we put a drop of hydrogen peroxide, and after a drop of phenolphthalein reagents. We wait for 5 seconds, and we can see that the swab is colorless and there isn't any blood in this case.
Forensic toxicologists perform scientific tests on bodily fluids and tissue samples to identify any drugs or chemical present in the body. As part of a team investigating a crime, a forensic toxicologist will isolate and identify any substances in the body that may have contributed to the crime, such as alcohol, illegal or prescription drugs, other chemicals, poisons, metals, or gases. We can analyze urine, finding the crime scene, or taken post-mortem. Some drugs have a higher concentration in urine and can remain for much longer in urine than in blood. So the range test is a test in order to detect heavy metal in blood. To do that, we need a little of chloride acid and a piece of tissue to analyze. And we have to put in a piece of copper. If the piece of copper became silver, it means that we have mercury in the blood, and if it becomes black, it means that we have another heavy metal. Here you can see that nothing happened, so in this blood we have no heavy metal.
Thank you for your presentation and your explanation. In conclusion, forensic science evidences are invaluable to the criminal justice system. It's why forensics chemistry, with all analysis it contains, is essential to the progress of criminal investigation. It provides evidence which, at the face value, seems infallible. It can prove one of two things: guilt or innocence of the suspect. The use of forensics evidence can trust most of the informations of an homicide, from the method of the murder and the time to the description of the killer and eventually his identity.